The Enigma of Robert Oppenheimer, From Science to Conscience. In the annals of scientific history, few names evoke as much fascination and controversy as that of Robert Oppenheimer, a brilliant physicist whose journey from the depths of theoretical science to the moral dilemmas of nuclear warfare has left an indelible mark on the fabric of our world. Born in New York City in 1904, Oppenheimer's early years were marked by a voracious appetite for knowledge. His intellect was evident from a young age, and he quickly rose through the ranks of academia. As a professor at the University of California, Berkeley, Oppenheimer captivated his students with his brilliant insights into the mysteries of the universe. His lectures were legendary, drawing students from far and wide. But it was during World War II that Oppenheimer's life took a fateful turn. Tasked with leading the Manhattan Project, he found himself at the forefront of the race to develop the world's first atomic bomb. The stakes were high, and the moral implications profound. As the project progressed, Oppenheimer grappled with the weight of his responsibilities and the implications of his work. On July 16, 1945, the Trinity test marked the dawn of the atomic age. The power unleashed that day would forever alter the course of human history. Less than a month later, the world witnessed the devastating power of atomic warfare as bombs were dropped on Hiroshima and Nagasaki, bringing an end to the war, but ushering in a new era of fear and uncertainty. In the aftermath of the bombings, Oppenheimer found himself haunted by the specter of nuclear proliferation. He became a vocal advocate for arms control and spoke out against the dangers of escalating tensions between nuclear powers. Despite his efforts, the Cold War brought with it a dangerous game of brinkmanship, as the United States and the Soviet Union vied for supremacy in the nuclear arms race. But Oppenheimer's legacy extends far beyond the realm of science and politics. He serves as a cautionary tale, a reminder of the awesome power of human ingenuity and the need for wisdom and restraint in the face of technological advancement. Today, as we stand on the brink of a new era of scientific discovery, let us heed the lessons of history and strive to build a future where the pursuit of knowledge is tempered by the principles of peace and justice. Julius Robert Oppenheimer, the eminent physicist and father of the American atomic bomb, was born on April 22, 1904, in New York City. His father came from Germany as a 14-year-old boy. He later became rich from importing fabrics. At the age of 5, Robert collected mineral specimens. His grandfather sent him many interesting stones from Germany. When the boy was no more than 11 years old, he was accepted as a member of the New York Mineralogical Club. After graduating from high school, Robert entered Harvard University. He was going to study chemistry, although at first he dreamed of becoming a poet, then an architect. In fact, Oppenheimer pursued comprehensive studies encompassing the humanities and sciences. He studied Greek and Latin, physics and chemistry, and occasionally published his poetry. In 1925, Oppenheimer graduated from Harvard in 3 years instead of 4, and received a diploma with the highest grade, and went to continue his education in Europe. Cambridge, first studies of the atom. Oppenheimer was admitted to Cambridge, where he began work in the Cavendish laboratory under Rutherford. Rutherford's laboratory occupied then one of the commanding heights in the young atomic science. But soon Oppenheimer received an invitation from Max Born to move to the University of Göttingen, which was famous above all for its mathematicians, and immediately after World War I became one of the centers where the revolution in modern physics was taking place. From time to time, physicists from all countries came to Göttingen to exchange the latest theoretical findings or the results of new research. Bohr himself traveled there from Copenhagen to give lectures. The new ideas, which were so radically changing the foundations of the physical worldview, were taught by those who had created them, directly in the process of formation, and the students felt called to contribute to the construction of the theory. On May 11, 1927, Oppenheimer held an oral examination. Obtaining a doctoral degree at Göttingen required passing examinations, not just the defense of a dissertation. The applicant received excellent or very good in all subjects except organic chemistry. As for the thesis, Max Born characterized it as a work of high scientific value, far above the level of ordinary thesis work. The following year, Robert Oppenheimer visited the universities of Zurich and Leiden. At Leiden, he astonished professors and students by giving a lecture in Dutch only 6 weeks after his arrival. In 1928, Oppenheimer returned to America. In 1929, when Robert Oppenheimer set foot on American soil again, his early successes in Europe were already known in his homeland. English and German journals had published Oppenheimer's work on the application of quantum theory to the distribution of intensity between different frequencies of spectra and the behavior of free electrons as they entered the interaction space with atoms. After some hesitation, Oppenheimer chose the University of California at Berkeley, near San Francisco. It is said that when the dean of the faculty asked Oppenheimer about his reasons for choosing the University of California, Oppenheimer surprised him by replying that he was enticed by the rich collection of poems by French poets of the 16th and 17th centuries assembled in the university library. Of the papers published by Oppenheimer during that period, of note was a study of the transformation of lithium into beryllium by proton impact. As in his student years, Oppenheimer's interests were not limited to scientific research. In the German universities that Oppenheimer knew so well, the Nazis persecuted scientists of non-Aryan origin, and with them their colleagues who tried to stand up for their comrades. Prior to this, Oppenheimer had been rather indifferent to political events, but now he began to reflect, and when the threat of fascism loomed over the Spanish Republic in 1936, he openly advocated it. During this same period of his life, Oppenheimer had a relationship with a girl who introduced him to active members of the Communist Party in California, and it subsequently backfired on him. In 1937, Robert's father died, leaving his son a solid inheritance, which allowed him to systematically provide material assistance to anti-fascist organizations. However, this impulse soon passed. Tragic news began to come from the Soviet Union about the persecution of anti-fascist physicists who had tried to find refuge there. This acted as a cold shower on the pro-communist sentiments of many Western intellectuals. Oppenheimer withdrew from the Communist Party, of which he had never been a member, but could not sever relations with those who continued to fight in its ranks or sympathized with it. Among them were his close friends and even his brother Frank, who at the time was studying cosmic rays. The fission of uranium. The year 1931 was marked by an important discovery. During the bombardment of beryllium with alpha particles, a new, very powerful radiation was detected. Frédéric Joliot and Irene Joliot-Curie passed this radiation through paraffin and noticed that in the path of unknown rays appear protons, that is, positively charged particles that are part of the atomic nucleus. British scientist James Chadwick, supported by Rutherford, conducted an experiment in Cavendish's laboratory which revealed the true nature of the radiation of beryllium. It turned out to be a stream of particles that had the mass of a proton, but had no electric charge. The discovery of the neutron, so-called the new elementary particle, completed the Rutherford-Bohr model of the atom and led to the discovery of new ways to study the atomic nucleus and the realization of nuclear transformation reactions. When observing the nuclear reaction of uranium, it was found that its nucleus, after collision with a neutron, decayed into 2 lighter nuclei, which corresponded to chemical elements very far from uranium. The phenomenon of neutron emission led many physicists to the idea that if the fission of the first nucleus, located somewhere in the thickness of uranium, can create several neutrons, each of which will cause the fission of another nucleus, then each of the nuclei subjected to such fission will also release neutrons, and so on. A chain reaction ensues. Nuclear energy appeared as a source of energy that was incomparably superior to all other forms of energy known at that time, and this energy could be used for military purposes. Oppenheimer immediately tried to calculate the critical mass of uranium needed to cause a nuclear reaction, and during the next 2 years of teaching, he never stopped thinking about the atomic problem.